Today we're going to be looking at this. This is a Telesensory VA2001 or an Aladdin Pro Plus. This is a low vision magnifier. Now I picked this up at a thrift store for an okay deal, and I have some ideas for it. Now while I can do macro shots like this that easily match the capability of the magnifier, you guys don't see the setup that it takes to get this. I'm using a reversing ring with my camera with a full manual lens. This is at an aperture of f22 to get that level of focus. That means I need a ton of light, so every time I do a shot like this, I have to set up a light box that looks like this, which is time consuming and frustrating when I'm trying to move along in a video. So now you might be wondering, what good does this thing do you? Well, it has its own built-in light sources that allow it to illuminate whatever subject is beneath it. And it has a 50x magnification built in. Now it is black and white only, but its 50 times magnification makes it very good at what it does. Now there was a version of this called the Aladdin Rainbow that did have a color monitor, and I suspect that the camera might be the same between the two units. It could be cheaper for them to design one circuit to use one camera and not have to source a monochrome and a color camera separately for their designs. So I want to see if there is a color camera built into this. Now the reason I'm so interested in this thing isn't to do video shots like this. It's difficult to see the screen, and even if I put a color tube in here, it wouldn't be easy. It does auto exposure, which I can't adjust, so it's hard to match it up with the lights. Most monitors that I show on here, I carefully tune the brightness and contrast to make it look as good as possible in video with all of the rest of the ambient light. But I suspect that I could probably capture the video somewhere in this thing and convert it into something I can record with a computer. So I think it'd be fun to try and make this into a USB magnifier. Now let's go ahead and crack this thing open and take a look at what is inside. I haven't done it yet, so I'm not quite sure how easy this task is going to be. Another reason I think it's worth a shot to try and do this is because they have other models where the monitor is actually detached on a tray here and can be removed. So it would make sense if the monitor internally is even just VGA. That would work for me to be able to capture. It doesn't have to be composite or S-video, but it would be nice just because I would build in this ATI TV wonder. So I definitely want to take a look at everything that we've got going on in here and try and deduce what video signals there are. Now, there are 4 screws that hold on the back panel of this. And yes, my serial number does end in 1337. And once we get this off, we can see some of what's going on. So way deep in there, we can see one side of the PCB for the camera. And we can see on one side of it, there's a connector there. And it doesn't have too many cables going off. So it's either sending out a digital video signal, or it's already processed into analog at that point. Here we can start to see a circuit board that the video signal is connected to, but we can't quite see enough of it, so we're going to have to pull the shroud off for the CRT. After removing the 3 screws on here, I can remove this. I thought I was going to have to remove this knob, but apparently not. Alright, we're getting a lot closer now. The inside of this thing is really nicely made. We have this solid metal cage inside, but that's kind of necessary for how far it hangs forward, but it makes it feel really good. They do have these separate boards all over, so all of the different components are isolated, which adds credibility to my modularity idea of them being able to reuse different boards for different products. So before I start trying to measure stuff, figure out what's going on, especially on this connector coming off of the camera down in here, I'm going to look up some different model numbers, like the assembly number for this board, to see if this was used in the color versions as well. I'm going to see if I can find any part numbers on the camera board in the back there that would indicate color capabilities. And then I'm going to, well, if all of that is fruitless, start probing the video signals. I'll be really interested to see if the auto exposure capabilities are on this board or on there. Because if they're on here, that means you could probably override them and manually expose through this connector, which would be really nice because the auto exposure sucks on metal things. I'm going to start out by pulling off the sticker on here that's covering up all of the chips. The part number on this thing is pretty useless because it just brings up stuff about CVT transmissions. Oh man, it looks like they scrubbed this chip to get the part number off. That sucks. Let me see if I can find it with a different angle. I have to get it really on the side there, but it looks like it reads A1310A0 as the part number. It's definitely not as easy to see as the one below it. Signal processing chip for CCD monochrome camera. Well, that sucks. Well, if you're curious, there's what the CCD looks like. Being monochrome, that kills my initial idea of trying to make this a color display, but I could still try and make it USB. So let's see if we can still find a composite, S-video, or VGA signal on here. Well, while I'm in here, I'm going to go ahead and get some good done and deoxit this selector. Doesn't really feel any different, but I'll see when I've turned it back on if it looks any different. Well, unfortunately, it looks like the deoxit's not helping much at all, because that switch still sucks. Huh. Also, I don't think I have any video of this, but this knob that was here on the side has now changed which angle it's working on. I don't understand. I'm not quite sure why it exists in the first place. All it does is put some kind of weird selector or line on the screen. But before it was doing it vertically, not horizontally. And I unplug it. It goes back to being vertical. So I don't get it. I threw a little deoxit in this as well, just to, try and make it better, but I don't know. Maybe this is bad and it's supposed to be able to go full range from horizontal to vertical. I'm not sure. There's too many wires on here for one potentiometer as well, because that's all there is. So clearly this thing's meant to be complicated. Alright, it's time to start probing for video signals, but before I do that, I need to know what is what on this connector, because there should be a power and a ground somewhere on there. Thankfully, though, they have very convenient little test points over here, so I can just check against that directly. Alright, so every other pin is ground. And do we have any 8 volts? Nope. 5. Nope. 12. Uh-huh. Alright, so we have one 12 volt there. And half of them are ground. Okay. Okay, so if half of these are ground, and this one's 12, that means we have 1, 2, 3 signal pins. So I think the auto exposure I was thinking isn't too terribly likely unless it's a 1-pin auto exposure. Now there may just be a luminance signal in here somewhere, and we can try and just find that. So let's see if we can measure anything useful. Alright, so instead of poking around here blindly and trying to identify something that looks like video on a scope, I decided to take a look at the block diagram of the chip in the datasheet. Now, if we look here, we can see that we should have a video output on one pin, and that already has all the information already encoded into it, sync and everything. We can also see that we have some configuration pins on here, and those might be the other two. Looking at the two that I think are most likely to be useful, we can see that we have white level clip adjust and setup level adjust. So I think those are probably also pinned out to that connector. It was easy to just take out the CCD board because that pin goes all over. So we can measure it right here. So this is pin 32, the video out pin, the last one on the board. So that one immediately goes to the back side of the board. And it connects to this resistor here, which then comes over to here and then goes back to the other side of the board, which connects to this capacitor. And then this capacitor on the back side here connects directly to the yellow pin. So the yellow pin should be video. So I'm going to do that for the rest of the pins and see what else we have broken out to this connector. All right, well, it looks like this pin, the blue one, goes to the black clip point, which is a pulse. So that isn't as simple as throwing a potentiometer in there as I'd hoped, unless the control board uses a potentiometer somewhere, because there's sure a lot of trim pots on there to set the black level. So I might be able to do that and see if maybe they have just some kind of timer that I can adjust to change the black level. And it looked like this pin went to a different chip on there. So, well, this one right here. And I'm not really sure what that one's doing because I can't find a data sheet for that one. So I'm just going to poke around on those with the oscilloscope now and see what I can get. Okay, so here I am connected to the yellow pin on the input, and we have an image of Lincoln on a penny down here. And if we take a look at the scope, we have what definitely appears to be a composite video signal being sent. Now, all of this looks very typical for a composite video signal. So, let's see what happens if we try and feed that into a composite video monitor. Well, that's close, but it clearly isn't everything. The CRT image obviously looks better, so I think I'm missing some of the signal. Or maybe my horrible breadboard wires over here aren't quite doing favors to the video signal. Let me see if maybe I can get this cleaned up a little bit, but well, I'm definitely on the right track. Now that's looking a lot better. I piggybacked a real RCA cable off of the connector by soldering it on there. So this is a much cleaner video signal than what nasty garbage I was getting through a breadboard. So now I know I can add an RCA jack to the back and get composite video out. So this thing just gained a use. Something I think I glossed over in the beginning of this that I wanted to cover was how this thing chooses the correct exposure for the image. So if I back out a bit, you'll see that the penny will get darker. Man, that looks so much better on the LCD already. Well, this is pretty crisp too. So let's say I go back to the Commodore 64 cartridge here, all right? Oh, that's interesting. Ha 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 ha. Ah, well, that's fun. Anyway, we have the... Oh, wait a minute. Am I bypassing that part of the circuit? So what happens if I adjust... Oh, awesome. All right. So that's really nice. The image you get on the CRT is post-processed after the camera. I didn't know it was after the camera. I thought it was configuring the camera. That's probably the same as what this is seeing now. But I can set it to a higher contrast, and I can set it to inverted or really hard contrast and inverted. And I was really annoyed with how it chooses to auto-expose. So let me pick something more difficult like my bit set here. Now, clearly it has to do some auto-exposure for this. And yeah, that looks a lot better on here. But I still think that I should be able to get better control of this. Because it's, yeah, I would like to make this image overall brighter, but I can't because there's no actual controls for the exposure on this thing. So one of the other pins I was looking at was the black level, and that was supposed to be a pulse off of the blue pin. So let me see what that looks like on the scope. The black signal here is really faint, but it doesn't seem to correspond with anything I do to the display. Putting under different colors to try and make it adjust doesn't seem to make it do anything here. So I'm not quite sure what's going on. Clearly it adjusts, so I wonder if on the board it has some kind of loop back where it auto-exposes. That would be unfortunate and definitely not controllable. Unless I modified the board, I suppose. But it's getting a little deeper into this than I wanted to. Cartridge is a great example of the auto-exposing, so it's obviously totally black, and if I pull it off, you can see here how it changes the black level. If I put my hand on there, the cartridge becomes completely black, and the penny's hard to see, but then take my hand off, and it becomes brighter. So unfortunately, I don't think I'm going to be able to adjust that very easily. Because I can't leave well enough alone, here is a magnifier that's handheld on there, and I can start to zoom in, but the focus doesn't go far enough away. There's the dirt on the top of the glass. If I wipe it off there, that's kind of cool. But the focus, it can't quite make it to the penny with the enhanced magnification, which is too bad, because that would have gone significantly bigger. So I was hoping I could possibly enhance the magnification of this beyond 50, but the focus clearly isn't up to the task. While I was looking up the part number for that chip, I found a module similar to this one for sale. And now I'm wondering, how hard would it be for me to just make my own that uses a camera lens? Because this doesn't seem too bad to me. And if I could find a color one, then I could just make my own here. Because, yeah, that's kind of working. Maybe I'll be making my own color magnifier that's, composite video. There's a handheld Lincoln and a penny. Yeah, I think I might want to try making one of these myself. Alright, now let's start work on putting a video out connector on the back. So I'm going to use this old RCA jack that I scavenged, and I think this looks like a great spot to put it. There was probably going to be something here in a different model. Maybe a different model with video out would have had it there. So we're going to stick it there, which will allow me to just cut a hole in the plastic in the back, but not have to mount it to that. So it's still going to be easy to service. And so I know I don't have the interference problem I had with the breadboard setup. I'm going to use S-video cable. And I just so happen to own a spool of S-video cable, so I can just use that. After running my cable up through the chassis, I know I have enough, and I can go ahead and cut it and stick it on my connector. This time I'll go ahead and give you guys the full soldering experience on this thing. I didn't for the test cable because it's kind of a pain to work with these connectors, because you gotta rip out each one here, and then they're just tiny little loose wires, so you gotta try and solder on those, and it's not fun. Okay, so here are the loose wires we need to solder to. This one is video, and that one is ground. I'm sure it's just a coincidence that yellow happened to be video, but it does make it easy to remember. Now, I need to strip open my S-video cable here, and these aren't super easy. I'm only going to use the yellow side for this, because S-video has chrominance and luminance. We only have a luminance, really. Unlike composite, S-video should be shielded like this, with the ground being around the signal portion. Okay, so now we need to solder these on, and that is going to be every bit as tricky as it seems. As a matter of fact, I think I'm going to give myself a little extra here. Not sure how well this is going to work for the signal cable, because it goes pretty far into the connector, so it needs to be really far back on there. I'm going to start out by adding just a little bit more solder to the back of this. That was way too much. And then see if we can get it to cooperate here. That wasn't too bad. Now, ground. I think those are going to work out pretty well. See how easily they go back in. Hey, I think that wasn't half bad. Either one wants to pull out. I think I'm good. All right, now let's do the other end. Now this should be much easier for this thing. So, same story. Strip this back. And go ahead and solder on ground first. And then the actual video signal. Well, that shielding worked out great, but whatever, doesn't matter. Alright, so I am going to take the super lazy way out and just put this on the back and then hot glue it in place. But first I need to put the cover on and mark where the hole needs to be drilled. And I'll do that by stacking up some stuff and then putting a pen up to the tip of this, and then making a mark on the outside where the connector is. Alright, that lines up in a pretty good place for the hole to be drilled. So let me slide the cover on and then make the mark. It'd help if I didn't use a Sharpie that was totally dry, but at least there's something there. Make that a little bit better. There we go. So that is the center point. This looks like a good sized bit, so I'll go ahead and drill the hole with this. All right, now I've taken a smaller drill bit and I've already kind of poked the center of it to act as a guide. So let's drill a pilot hole. All right. Now I think we can just go for the big one. The hole was definitely big enough for the RCA connector, but it doesn't poke through as much as I thought it would. So I'm going to have to make the hole bigger so the outside gets a proper connection. I think that will be good for most video cables. That hole feels pretty good for a normal video cable. So I think I'm going with that. Okay, now there's the final product of how the connector went in. And if I attach one side and put it on there, you can see it fits pretty well. However, cable connectors aren't super great on there. So probably could drill out a bigger hole. But I think just cutting off a little bit around the end of this is just going to be the better solution. I don't think there's too much more to do on the inside of this thing. The CCD didn't end up being color, so I can't really do anything more with that. I could possibly get a color one and put it on there, but I doubt this board supports it, so I'd need to replace that, which I imagine isn't that fun, but it mostly is just a composite to CRT adapter board, but it has all the controls I need, so nah, it's not worth it. So I'm going to go ahead and put this back together, and let's play around with it a little bit, especially now that I have a video out and can just directly capture it. All right, so here we are. We have the Aladdin Pro Plus set up with a subject here, and I'm successfully doing video capture. So here is the first thing we'll take a look at. This is just a soldering sponge, and we can see all the porous structure in there because it's a sponge, and yeah, we can see a lot of hair and threads and stuff that have gotten stuck in it as well. Yeah. All right, let's take a look at something else. All right, so here we're comparing the difference between a Samsung Galaxy S5 display and a Nexus 6P display. And there's the 6P display. You just can't quite make out the pixels on the 6P, I'd say. The more pattern is just a bit difficult, and the S5 has decided that it's going to restart. Actually, this is kind of interesting. So right now, only the red LEDs on the display would be lit up. So that should just be red. So actually, let's try and find Verizon's logo again. So that would be white versus that. Yeah, that's kind of cool. So red, which would be 1/3 of the LEDs, versus white, which would be all of them. All right, so here's red on the 6P. And compare that to red on the S5. So what is the PPI between these? Well, this is interesting. The 6P should be 515 pixels per inch, and the S5 should be 326. I would think the difference would be much more significant between the two, with those numbers being so far off. Now I'm thinking that the more pattern on the 6P is probably a lot more significant than I'm initially giving it credit for. Here we have a commercially produced CD, and you can start to see some of the tracks on the CD's data layer. Kind of interesting. Here is the backside of the leather case for my Kindle DX. And on top of that, I'm going to put some popcorn salt. Now let's zoom in, and we can see the individual cubes of salt. Ooh, there's a big one. Right now, here I have a circuit board, and this punchy, high-contrast image you're seeing is exactly how I see this in person. It's really difficult to make things out. It's clearly amplifying the whites and subtracting the darks. So on here, I can't really make out the chip part number. It is slightly faintly visible, but not really. But over there, on the screen-captured one, it's clear as day. So... and there is no setting on here. I mean, if I can make it worse, I can't make it better. I can invert it, which actually is really a lot easier to see. And it's kind of interesting because I'd noticed this before that with inverted, it's really easy to see the chip markings. So it's clearly doing some kind of, contrast stretching manipulation with the video when it's doing this change here. But this should be straight and clearly isn't. Now, if I zoom in, we can see on here that you can't really make out the points where that capacitor is touching the solder because it does that stupid contrast stretching. But on the regular screen capture over there, it is again clear as day. That capacitor is fully soldered down. So while I couldn't use this in person to double check electronic stuff, I probably could use it over video capture. Too bad I just have to have this giant thing sitting on my desk that I'm not even going to look at. But now that we're here, let's go ahead and take a peek around, because it is pretty cool. Look, there was a hair on there. There's a 0 ohm resistor. We have a oscillator, and I can't read that on the screen, but on the video capture, it's pretty obvious that it's a 39 megahertz. Yeah. And for the final thing, let's take a look at the bottom layer of something that's been 3D printed. So we can get in there and we can see the individual strands of plastic that went into that. So, while this is the bottom layer, there are some layers that are just above bottom here in the middle now. Lots of different quality. This wasn't the best print. Let me find something that went a little better. There we go. It's not a bottom layer, but that'll do. And this is gray, which is interesting because the auto adjust isn't trying to make it totally white and totally black. It's just leaving it alone. So there's clearly a limit on that. Well, I think that about wraps it up for the Telesensory VA2001 or the Aladdin Pro Plus. It's kind of cool. Got the 50 times magnification, which is significantly more than that. But ultimately, monochrome, not terribly useful. The video out definitely makes it a lot better, and that it's a much cleaner signal as well really helps. So I may use that in the future. I'm not sure. But for now, I need to get it off my ESD Mac, because it's done really horrible things to it. So I'll see you guys later.